Hello and welcome to this tutorial where I will go through a little bit how we are going to work with the exercise that I've already been giving you. So I have printed this paper which you can also do if you want to, but if you don't want to, you can just as well use a blank sheet of paper. So for this exercise I'm going to use this Duplo model, which consists of 1, 2, 3, 4 different pieces, and you can see one of them is very unique and can rotate, and this one has a print on it. This one is circular, and yeah, this one is some sort of arc. So let's move on with this printed material. So the first exercise is called Analyze the Model, and if we look down here, there are a couple of things to help us. Analyze and define each given brick as a separate entity, list unique and common features, what make each brick unique, what is common between all bricks of blocks, block of bricks, write to conclusion, use the backside if not enough space. So they are all Duplo. They have a height. They have a height. They have a width. Some of them can rotate. They are not all square, so this is some sort of unique shape. Most of them, but what shall we call them? They have a height. These ones have the height twice the height of this one. This is actually it's less than 2, as you can see, but it's more than 1. So this is 1.5 height in halves. And then we, as I mentioned, we have something called a print. And with this thing here, we have orientation. This one rotates. Do we have a 0? Maybe we do. For example, if we look carefully into the piece, we can see that it's printed Lego in there. So we could maybe define the 0 depending on that logo 0. There are actually some holes here. I don't know if that makes any use. Maybe it's just for water to leak out. I don't know. We can see that these also have the Lego brand printed to them, so it should be possible to separate the printed side from the unprinted sides. Common feature, they all have these bosses, but you know, maybe that's somewhat connected to the height and width. We don't know that, but this one just have 1 on top and 1 on bottom, but it's still bigger than this one, which makes it a little bit interesting to think about. This one only has 4 in the bottom, but 8 studs on top. So yeah, so these are basically the conclusions from this analysis. So let's put it back together. I think this is somewhat how it was. And move on to part 2. So in part 2, we are about to define the general structure of all these parts. So define a general structure that is applicable to describing all your Lego parts using UML class diagram. And that is what we have here. We have object name, object attributes, object functions. List the name of the attributes needed, for example, weight, cost, size, things that characterizes the brick. and may be useful for design, manufacturing, etc. I actually do not think that weight is relevant for this thing. They all have a weight. It's the same material, so it shouldn't really affect it. But of course, the easy thing here to look at would be size. Cost is probably irrelevant for our purpose as well. And other things that characterizes the bricks, such as maybe the prints and the different shapes. So just to get started with this one, I would go on and call this Duplo brick. And thinking about what we talked about before, we have width, we have a height, and we have a length. Then of course we have to define what is what, but the computer cannot do that for us. And then we have this sort of thing, print. So I guess the answers of this would be a numerical value, but on this it would basically be yes or no, or it would be the name of this, so like star print or something. And then, so how do we divide the square-shaped ones from the circular-shaped ones? We probably need some sort of shape, and here we would probably have predefined attributes saying something like square, cylindrical, and then we would name this. We would have to call this a swirl or something. And this thing we would probably have to call an arc or something. And then of course, if we have several pieces with arcs, we would have to call them different things, like arc 1 or arc 2, something like this. But I think these are fine for now. Maybe we also talked about orientation. It is not going to be interesting until we put them together, but just to make sure, we put that in there. And that would probably be done in degrees, I guess. We could use it in radians or milliradians or something else, but degrees would probably be the easiest way. And object functions, they all have the same one as in the Lego example from the exercise. So they can connect top, connect bottom. So I think this is actually a fairly good description of what this one can do. Let's put it back together and move on to part 2.2. So in this exercise, we are going to reuse what we did here. So we're going to use these attributes in order to describe what we had here. So Duplo brick was the generic name. Then we have to make up a specific name. So let's start with the easy one. So let's call this blue standard brick 2x2 with star print. Okay, that's a very complicated name. You would probably like to call it something else, but it's also a little bit intelligent, because when you get into this, you would know what that means. But now we start looking at the attributes. So which attributes did we have? Width, height, length. Let's do it in the other way. Length, height, something like that. Yeah, whatever. the computer will remember what was written there. So width, it's actually, so let's put it on 0 rotation. So it's 2 width and 2 length. So we put those in, 2, 2, and height. As you remember, we said that this was 1.5 high, so we should probably measure the height in halves. So this would be, let's call it 2 halves, which of course become 1, but it's probably easy to call it 2 halves. And let's see what other attributes we needed. So print, it has a star print, and if we are careful now, we can see that it's actually on the left side. So we can actually put a function here if we wanted to. I don't say you have to, but let's call it star print, and since it's on the left side and we use degrees, we can say it's on 270 degrees, on the side with 270 degrees. So here's 0 orientation. Here would be, I don't know if we should, maybe we should call it, it depends if you rotate it. Okay, so let's say we rotate it in that direction. So this is 0 direction, and then we rotate 90 degrees, 180 degrees, 270 degrees, and there it is. So star print at 270 degrees. And rotation, well, rotation is actually irrelevant now because we're just describing this one. You could probably put rotation as a function also, but let's just put rotation at 0. And shape, I forgot shape, put it in here. Shape, let's just call it either standard or square or edgy, or let's write standard. And since it's by itself, it has 0 function, and both of the functions are not relevant or not applicable, so we just write it like that. Okay, let's do one more. Let's do this one. So what shall we call this? We should actually add color here. And of course, you can call this blue, and you can call this blue also, but it's not the same blue. So maybe we want to call them blue 1, or we want to give them like RGB code or whatever. I don't know how to write RGB code for that code, but let's just say it's like, let's write white, which would be a lot of zeros. 1, 2, 3, 4, 5, 6. Yes. So moving on to this one, then we remembered, okay, we forgot color here, so we add a color. Remember that this happens all the time, that you forget that you didn't have an attribute, or you needed a new attribute, and then you went back and added it. So let's do the second one. What shall we call this one? It's a swirl. It's quite difficult to say what size this is, but let's call it swirl 2 by 2. Yeah, because it has that, and it's, yes, just call it swirl 2, but it doesn't really matter what we call it. But okay, so what's the width of this one and what's the height? If we use the studs to measure the height, it actually is 1 on each. So width is height is 1, length is 1, height is 3 halves. Print, not applicable. Shape, what did we call this shape? Swirl. And then of course the computer has to look up swirl, and it's like defined in a CAD drawing or whatever what exactly is meant with swirl. Rotation, it's actually 0 because it's not relevant here really. And color, it's, let's call it blue 2. And it has another RGB code, but we just put white there because that's easy. Or if it's black, I don't know. It's actually black. Everything is off, then it becomes black. And it's the same thing with the function. And then I guess you would be able to continue with these ones yourselves, or if you have another piece of Duplo, you would be able to describe those. Okay, and moving on to part 3. Now we should start define the connections between the bricks and the product structure. This can, of course, be a little complicated. Define a general model to describe how bricks are connected to each other. Design a model or product structure showing the interfaces as a very basic UML diagram. You can describe the connections as functions. You can write the connection principles of links between UML objects. Do you have a system for indicating rotation? We actually do, right? And then there was the process part. So we'll do a simplified UML model. I'll just take another pen here. So how do we do this? We can just say, okay, we have a Duplo assembly as the top node. And that consists of module 1 and module 2. Let's say that these are the different modules. It makes sense then when we manufacture them. And then we have part 1, part 2, part 3, part 4. That's just 1, 2, now I ruin everything, 3, 4. Just to make it, because I gave them a super complex name, right? So we just renamed them part 1, part 2, part 3, part 4. So this is the assembly, and it consists of, then we can put in something like this, and module 2 actually consists of blah blah blah. So there we go. And these are the actual physical parts. So then we shall try to describe how are these modules assembled. How do they connect to each other? And then, of course, we can start calling these. If you remember the example, we could see that, okay, we could give the studs different names, and then we can make sure that they are connected to different places. Now things becomes very complicated, but just to mention the principles here, we can see that this one, according to our principle, should be rotated like this. So then we actually have to rotate this 90 degrees to get there. So then we add rotation 90 degrees to this one. You remember it's actually like that. And this one, rotation doesn't really matter. So we can say that rotation is 0. And all the other attributes here, you have them from the last exercise. You don't have to write them up again, right? Should make sense. So rotation is 90 degrees. And then we had the functions connect bottom and connect top. So this is how it's supposed to be. So this one is connected on top. It's connected on all 4 studs. Actually two module 2. So we should of course have it's connected to module 2. And it involves all of them. So we can just, if we name them 1, 2, 3, 4, or A1, so it's A1, A2, B1, and B2. They're all connected. So for this thing here, we just decided to call the studs A, B, 1, 2, and then A1, B1, A2, B2. Something like that. And that one is connected on top to module 2, and on bottom it's the same thing. On bottom it's connected with all of them to number 2 here. So it's connected to part 2 with all studs, like A1, A2, B1, B2. And then we can do part 2. We already said it's rotated 90 degrees, which it's there. And then this one on bottom, it's not connected at all. So that's very easy. It's only connected to this one here. This one is connected with all of the studs, but this one is only connected with these ones. So if we do the same, we should, since it's rotated, we should actually put it like that, because this is the 0 rotation. And the 0 rotation is when you can read out the Lego logo. So then we call them the same thing, A, B, 1, 2, 3, 4. It's connected on these 4, which is A2, B2, A3, and B3. So then we can write that in the connection on top. We write that it's connected to part 1, and it's connected on A2, B2, A3, and B3. And if you remember the example from the lecture, it said rotation down there, but now that's not needed because we have actually put the rotation up there, which we might actually want to go back and update to make sure that, let's rename this to make it a little bit more simpler. So this is part 1. This is part 2. This is the one with the print. So this is part 4. And this one is the swirl. So we can just call it part 3 instead. And then here on rotation, we would like to add on part 2, it should be rotated, because this is a standard rotation. It should be rotated 90 degrees. And when it comes to part 4, which is there, we want it like that. So we want it like that. So then we have to check what's the rotation. It's actually yeah, we actually wrote it. So we have the print at 270, so the rotation should be at 270 to make sure it's shown. And this one we decided it should be there where I wrote the number 3. And that is a little bit more difficult. So we rotate it minus, so let's say this is plus rotation. So it's about minus 60 degrees or plus 300 degrees. So let's say it's rotated 300 degrees. And then we have them all set up like that. So that was showing you a little bit how to work with this. I hope this was not more confusing. And I think when you sit down and do this, you will realize what to do here. So for example, you could add multiplicity here, saying that each duple assembly have one module 2 and one module 1, and it has exactly one part 1 and one part 2 and one part 3 and 1.4. Just to finish up this lecture, for you who have been observant, this is of course not going to be the superclass to subclass connection, but it's going to be the whole to the part, which I said in the lecture. If it is a product structure like this, the diamond shape is the thing to use, which basically means that this is the whole and this is the part. So the whole duple assembly consists of two parts, module 2 and module 1. Module 1 on the other part consists of two parts, part 1 and part 2. So just to, it should have been the open ROM like this. So make sure that you do that. And we cancel that out. Okay, just a quick reminder to make sure that you have your head with you.